Welcome to Maths with EJD. In this video, I continue with method of variation of parameters for non-homogeneous second order ordinary differential equations. So far we've seen that non-homogeneous, for non-homogeneous second order ODEs, okay, which is generally okay, well, let me not go there yet. I'll still get there. So we've looked at methods for solving them, right? So like undetermined coefficients, where you guess a possible result, and then you now determine the coefficient later. And then in the last video, we looked at D operator techniques, D operator method or D operator techniques, where you use D operator and inverse D operator. Use the operator to get the complementary solution and use inverse the operator to get the particular solution. So in this case, we are going for variation of parameters, okay? Variation of parameters. So, like I said, right, we've taken care of undetermined coefficients, we've taken care of the operator, and the focus shifts to variation of parameters. So let's have an overview of variation of parameters. Variation of parameters. So here, variation of parameters is a method used to find a particular solution, to find a particular solution to a non-homogeneous, linear differential equation of the form y prime prime plus p of x y prime plus q of x y equals g of x. And like we know, um, g of x is what makes it non-homogeneous if g of x is not equal to 0. So if g of x is 0, then that thing becomes it becomes homogeneous. And by solving that, we get a complementary solution. But if it's not equal to 0, we have the non-homogeneous expression. So the next thing we want to do here is to look at some steps for variation of parameters. Variation of parameters. Okay. So the first step is to solve the homogeneous equation. Solve the homogeneous equation. Okay. So solve the homogeneous equation. So first, solve solve the corresponding. That's what we've been doing all along as far as non-homogeneous equations are concerned. Solve the corresponding homogeneous equation, which is y prime prime plus p of x, y prime plus q of x, y equals 0. Solve this part. Okay. Then in solving it right, solve this. So when you solve this right, you solve it to find two linearly two linearly independent two linearly independent solutions two linearly independent solutions, y1 of x and y2 of x. That's really important. Y1 of x and y2 of x. So when you solve like that, that's what you're going to get. So those y1, y2 are really important. So pay attention. And then we go ahead to step two. In step two, you now assume a particular solution. So for for method of undetermined coefficient too, we had to guess a particular solution. But the approach here is like that, but a bit different. So you assume here, the particular solution, assume the particular solution is of the form, is of the form yp equals u1 of x. I mean, I should, like I've always said, right? This is yp of x equals yp of x equals u1 of x, y1. You know, that y1 you would have got up there, y1 of x plus u2 of x, y2 of x. Okay, so this is what you assume your particular solution to be. All right. So where u1 of x and u2 of x are unknown functions, they are unknown functions to be determined. So the determination of those functions is what is going to give us the particular solution in this situation. Okay. So the next thing you're now going to do is to find, so you now want to find in step 3, find u1 of x and u2 of x, okay, by differentiating yp of x, the yp of x up there, okay? So you differentiate the yp of x, you get up there. So, if you differentiate this yp of x, so you're going to have, it's a function of a function all the way, like you're going to have plenty things. So that means you have yp prime of x, that's the derivative. So that's u1 prime of x. Okay, let's remove the of x to make things easy. So we don't, I mean, we can save a lot of stress with that. So you have yp prime equals u1 prime y1 plus, you know, um, u1 prime, right? Y1 plus, you can also have u1 y1 prime, okay? That's function product rule. Then you also have u2 prime y2 plus u2 y2 prime. Basically, that's what that looks like, right? So uh in this case now, so see what you have. So it differentiates u1, you keep y1 constant, and you differentiate y1, you keep u1 constant. That's how you get this two. You do the same for the other side. Okay, so and the next thing is to simplify calculations, So you impose the condition, impose the condition that uh impose the condition that u1 prime y1 plus u2 prime y2 is equal to 0. Okay. So what we are simply saying is that u1 prime, this one and this one, they are equal to 0. So at the end of the day, you only have u1 y1 prime plus u2 y2 prime for yp, right? So because we want to simplify, right? So we just impose this condition on the system, right? Um, so uh this this reduces yp prime to yp prime equals u1 y1 prime plus u2 y2 prime. So this is what yp prime becomes now. So with this in place now, we now differentiate again. So differentiating again, second derivative. So we now have yp prime prime to be again from what we have. So that's u1 prime, okay, y1 prime plus u1, okay, u1 prime, y1 prime plus. So that's differentiate u1 and keep y1 prime constant. Then now keep y1, u1 and differentiate y1 prime. That's y1 prime prime. Okay, do the same for u2. So you can have u2 prime, y1 prime plus keep u2 fixed and differentiate y2 prime. So that's y2 prime prime. Basically, that's what we have there. So this is what yp prime prime becomes. Okay, function of a product rule still, right? So you have u1 y1 prime. So differentiate u1, that's u1 prime. Then y1 prime is fixed. Then now hold u1 and differentiate y1 prime. That's u1 y1 prime prime. Do the same for the other side. So you have u2 prime y1 prime plus u2 y2 prime prime. Basically, that's what we have in that situation. All right. So The next thing we want to do now is we want to, that's step what now? This is step three so far. Now step four. So in step four, so we want to set up, so we need to set up the system of equations, the system of equations. Not to worry. At the end of the day, the implementation is something very simple. What we're doing here is just some kind of derivation. So follow carefully, right? So set up the system of equations. So to set up this, so here now we now substitute. So we substitute yp prime prime and yp prime, just like we did for undetermined coefficients, into the original non-homogeneous equation. That's going to be a lot already. Into the original non-homogeneous equation. So when we do that, we get something like, so we have for the second, what's the original expression now? We have y1 prime prime, right? That y1 prime prime is the first part, and for y1 prime prime, what we already have this plenty thing, okay? So we have y1 prime, yp prime prime. So it means we have u1 prime plus y1 prime plus u2 prime, y2 prime. That's for y1 prime prime. Um, okay, let me just write this out. Then that now goes to be p u1 y1 prime plus p u2 y2 prime, okay, plus q u1 y1. So some representation is already there. q q u2 q u2 y2, okay, and that is equal to g of x, okay, that's equal to g of x. So here now we say, since y1 and y2 satisfy the homogeneous equation, the homogeneous equation, okay, their terms cancel out. That's why you can see that that one is actually simplified. Their terms cancel, leaving their terms cancel, leaving. So you now have u1 prime, y1 prime plus u2 prime, y2 prime equals g of x. So that's all we are left with because of the homogeneous equation being satisfied. So together, together with together with the earlier condition, remember the condition we imposed, together with the earlier condition, all right, we have u1 prime y1 plus u2 prime y2 equals 0. We had this condition in place the other time. So it's more like we want to solve simultaneously. So you see that this forms a system. This forms a system of two equations in u1 prime and u2 prime, which is now like u1 prime y1 plus u2 prime y2 is equal to 0. And then you have u1 prime y1 prime plus u2 prime y2 prime is equal to g of x. Okay, so that's step 4, right? Now we actually want to you are looking for u1 and u2, right? u1. So in step 5 now, we we have to solve for u1 prime and u2 prime, from this system of equations. It's a simultaneous equation we can solve for sure. And when we do that solving, Um, okay, we solve this system using determinants and we get u1 prime equals minus y2 g of x all over w of y1 comma y2 um and u2 prime would be y1 g of x. If we solve that equation up there, right? And that would be w of y1 comma y2. Okay. So you'll be wondering, where is this w thing coming from? So you should know that w of y1 comma y2 is the Wronskian. Okay. So the Wronskian is the Wronskian, which is w of y1 comma y2, and that will be y1 y2 prime minus y2 y1 prime. So all of that is coming from this system of equations, right? So so now we have got u1 prime and we have also got u2 prime. But what we're actually looking for, we are actually looking for u1 and u2. But I mean, it's good that we have got u1 and u2 prime, u1 prime and u2 prime, because now we can integrate them to get the actual thing we need. Okay, so that takes us to step 6. So in step 6, we integrate, to find u1 u1 of x and u2 of x. Okay, so we integrate to get that. So at least we have u1 prime and u2 prime now. So we can get u1 of x and u2 of x. And how that simply works is this, that u1 is equal to integral of minus y2 g of x all over the Wronskian of y1 comma y2, and that goes. And then we also have u2. Okay, u2, that is integral of y1 g of x all over the Wronskian of y1 comma y2 dx. Okay, I should put dx here too, dx. Okay, so that is now u2. And once we get this, we can then find in step 7, right? Step 7, the particular solution. So step 7, that's the particular. So find the particular solution. Find the particular solution. Find the particular solution. Okay. That is now yp of x. Or let's just leave it at yp first. Yp is u1 y1. That's where we came from, plus u2 y2. So you can find this now that you know u1 and u2. So you can fix it up and you have your yp. Okay. And then that takes us to step 8, where we find the general solution. Step 8, the general solution. Okay. So the general solution, the general solution to the differential equation, is y equals c1 y1 plus c2 y2 plus whatever we get as yp from all that long process, okay, where c1 and c2 are arbitrary constants. They are arbitrary constants. I mean, we've used this a lot. The arbitrary constants determined by initial or boundary conditions. Initial or boundary conditions. So if you have initial conditions or boundary conditions, you can get rid of the constants. Okay. Now, that we have done all of that, I think it's important. I'll just do one example. I won't do all the three examples I'll be doing for the other methods. So let's go for this. So I'll just take only one example. And then interestingly, it's the same approach all the way. For the it's not like for the other method where you have to keep varying. So here it's you just need your U1, Y1, U2, Y2, and then you do the same thing. So I'll just solve the first example here. Solve Y prime prime minus 3Y prime plus 2Y equals e raised power x. So here we are using variation of parameters. All right. So we need to solve this. So the first thing we do is this. Go for step one. So for step one, find YC of X. That's the particular solution. So using, of course, I mean, if no method is mentioned, the original thing is the, what is that thing called now? The characteristic equation. Using the using the characteristic equation, right? That is for non-homogeneous part now. So, I mean, to find y of c, right, isn't the characteristic equation of, the homogeneous part. That is y prime prime minus 3y prime plus 2y equals 0, which is, which is r squared minus 3r plus 2 equals 0. That's what the characteristic equation will be. And of course, I explained this under the homogeneous part, how we arrive at this. We assume that y is equal to e raised power, y equals e raised power r, rx as the solution. And then we expand and substitute, and then we end up getting this. So you can check that first video in case you have not seen it. So this is r minus 1 into r minus 2, and that is equal to 0. So that means that r1 comma r2 will be 1 comma 2. So we have this, right? So that yc of x would be c1 e raised power um, r1x plus c2 e raised power r2x. So that means that yc of x again is c1 e raised power x plus c2 e raised power 2x, because r1 is 1 and r2 is 2. So with this in place, we go for the second step. So in step 2 now, we want to find yp of x. Find yp of x. Now this one has several steps. So the first step under this step 2 is to first of all assume, okay, assume that yp of x is equal to u1 y. Okay, I mean, I'll do all this story, right? U1 of x, y1 of x plus u2 of x, y2 of x. That's what we're assuming. And how do we know what we'll be looking for y u1 and u2, but we already know y1 and y2. So this is y1 of x, that's e raised power x, and this is y2 of x, okay, like that. So that means that yp of x is equal to u1 of x e raised power x plus u2 of x, okay, e raised power 2x. So this is that already. I mean, to make things easier, we can just say yp is u1 e raised power x plus u2 e raised power 2x, because we have a lot of things to do. So we have this now. So with this in place now, we can go for the next step, right? Okay, let me go this light blue this time around. So that's step 1 there. So step 2, we can find the run scan. So the run scan, we can say we obtain the run scan. We obtain the run scan of the system as follows. Okay. We get the run scan of W1 of and W2 is simply the determinant of Y1, Y2, okay, And then we have y1 prime, y2 prime, basically. So that's what the Wronskian should look like, because normally Wronskian should be y1, y2 prime plus y2, y1 prime, like that. So W of y1, y2 is simply the same as the determinant of, so your y1 is e raised power x, y2 is e raised power 2x, right? So that we now have differentiate e raised power x, we get e raised power x. Differentiate e raised power 2x, we get 2 e raised power 2x, basically. So the Wronskian y1, w of y1, y2 is simply this e raised power x multiplied by 2e raised power 2x minus this, that's e raised power x, e raised power 2x, like this. So that w of y1, comma y2 is simply the same thing as 2e raised power 3x, okay, minus e raised power 3x, okay? So that's 2 of this minus 1 of that. So the Wronskian is simply w y1, comma y2 is simply e raised power 3x. So this is our Wronskian, which is really important here. And now that we have this, then it's easy to take care of the rest, right? So I go for step 3. So in step 3, right, then we can find u1 prime and u2 prime. Okay, find u1 prime and u2 prime. So u1 prime is equal to minus y2 f of x all over the Wronskian, and that is simply minus y2. Don't forget y2 is e raised power 2x, right? So y2, or even from here, we know that y2 is e raised power 2x. So we have minus e raised power 2x dot f of x. F of x is that non-homogeneous part of the original expression. So this is our f of x here, right? It's e raised power x. So we have e raised power x all over the Wronskian, which is e raised power 3x. That's e raised power 3x. So we have u1 prime equals, if you put that together, you get minus e raised power 3x all over e raised power 3x. That means that u1 prime is equal to minus 1, okay? u1 prime is equal to minus 1. So we have u1 prime. Then u2 prime would be y1 f of x all over the Wronskian. So y1 is e raised power x, then f of x is e raised power x. The Wronskian is e raised power 3x, okay? So that means that u2 prime is equal to e raised power 2x all over e raised power 3x. So that means that u2 prime is equal to e raised power 2x, e raised power 2x minus 3x from law of indices. So that means u2 prime is equal to e raised power minus x. So we have u2 prime and u1 prime. Thankfully, we are getting there. So the next step is step 4 under this second major step. All right. So number 4 now. In this number 4. So find u1 and u2. Okay. So since, well, of course, we know u1 will be equal to integral of u1 prime dx. So that will be integral of u1 prime is minus 1, okay, up there. So that's minus 1 dx. So that means that u1 is equal to minus integral of dx. And that is simply u1 equals minus x, of course, plus a constant, which we don't have to worry about. Then for u2, we also know that u2 is equal to integral of u2 prime dx. And u2 prime here is e raised power minus x dx, right? So that means u2, when we integrate e raised power minus x, we have differentiate minus x to get minus. So that's like e raised power minus x divided by minus 1 plus a constant, which we won't worry about. So u2 is also equal to minus e raised power minus x, okay? Minus e raised power minus x. That is our u2, okay? So now that you have obtained all of this, then we can go back to the original YP we wrote, okay? So this YP now, okay? So, so, um, from yp of x equals u1 of x, y1 of x plus u2 of x, y2 of x, right? So we have yp of x to be u1 now is obtained as u1 is minus x. So we have minus x, y1 of x is e raised power x, and u2 is minus x, u2 is minus e raised power minus x dot y2, which is e raised power y2 is e raised power 2x from what we got initially. So yp of x now is equal to minus x e raised power x. Then from all of this, we have this is minus, right? So so this is minus e raised power minus x plus 2x, okay, from the law of indices. So yp of x is equal to minus x minus x e raised power x minus e raised power x again, okay? Minus e raised to our x, all right? So this is our yp of x now, okay? So, so step 3 now, the general step 3, if you like. This is now step 3, the overall step 3. Find the general solution. Find the general solution. So of course we know that is always y of x, which is equal to yc of x plus yp of x. Okay. So this is yc of x plus yp of x. So y of x now would be, so yc of x that we got initially, it's been a long time ago, so to speak. Yeah, it's c1 e raised power x plus c2 e raised power 2x. Okay. So this is c1. So c1 e raised power x plus c2 e raised power 2x plus yp. Now yp of x now is okay, I mean it's okay. I just say minus x e raised power x, right? Minus e raised power x. Okay. So that yx now is equal to c1 is equal to c1 e raised power x plus c2 e raised power 2x minus x e raised power x minus e raised power x. Now, the thing here is that, these two, this e raised power x and this e raised power x are about the same thing. So we can factorize. So we have y of x equals c1 minus 1 e raised power x. That's putting those two together plus c2 e raised power 2x minus x e raised power x. Okay. So we can just say c1 is constant, 1 is also constant. So we can say y of x equals c3 e raised power x plus c2 e raised power 2x minus x e raised power x. uh this is the general solution now. Now this one looks very well like when we did undetermined coefficient and the other, and even the d operator method. For the d operator method, the only thing is that we have to transition another constant, but a constant is a constant at the end of the day, so it doesn't really make so much difference. Okay. So in this case, now we can then still go further, right? We can then still go further and still put all the EX together. So we have y of x equals C3 minus x e raised power x. That's putting this and this together. So we have C3 minus x e raised power x plus C2 e raised power 2x. So this is now the general solution. Okay. So in the other cases, like we had C1 minus x e raised power x plus C2 e raised power 2x. But because we had another EX showing up, that's why we had to do this. All right, so I won't do the other the other two examples, because I mean this has taken so much time, and I think the point has been driven home already. But of course, you can be sure you will have some practice questions to play with. Okay, so let's deal with this. Um, okay, let's take some practice. Solve the following. solve the following using variation of parameters. Using variation of parameters. Okay, like you discover that under differential equations, I've been given a lot of tasks because the questions are really easy to write. So y prime prime minus y equals e raised by x, variation of parameter two, y prime prime plus y equals tan x. And here we have 0 to be less than x, less than pi over 2. That's to guarantee that x doesn't slip out of, it doesn't go undefined. I think that's the purpose of that. Number 3, y prime prime minus 3y prime plus 2y equals e raised to power 2x, all right? Then number 4, y prime prime plus 4y equals cos 2x. Number 5, you have y prime prime minus y prime minus 6y equals e raised to power 3x. Then we can get some more advanced problems like number 6, y prime prime, okay, plus 9y equals x squared, Then number 7, um, y prime prime plus 9y equals x squared. Okay, number 7 can be y prime prime plus y prime minus 2y equals 1 over 1 plus e raised to power x. So the right hand side is some kind of saturating some kind of sigmoid function or so. Then number 8 can be y prime prime minus 4y prime plus 4y equals e raised to power 2x all over x plus 1. Okay, some serious task right there. Then question 9, we have y prime prime plus 2y prime plus 5y equals e raised to power minus x cos x. All right, so let me see your answers in the comment section, either on Facebook or on YouTube, okay? And of course, let me know also in the comment section if you have some questions you'd like me to solve or problems or topics you'd like me to teach. Then if you have not subscribed, you'll be missing a lot because there's a lot more coming. After this, now I'll be talking about applications of second order ordinary differential equations. Very important. So you want to subscribe and hit the notification bell so you can always get alerted each time a new video is released. And don't forget to like and share so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.